Morning, hi guys. Today before we go into amines, continue with basicity, I want to just I think I forgot a bit about the reactions of phenol. I didn't express it, but I thought I should express it now. Okay, page 64. If you go to notes. Okay, now here in this part here. See, after you see for phenol amine, what is phenol amine here? Phenol amine later you'll find is phenol amine is I say still not used to this yet. All right, phenol amine. Phenol amine is this part here. Okay, it's an aromatic amine. Now this fellow here is called phenol amine. Sometimes it's called aniline. Okay, now this and your phenol, well, they are very similar sometimes in reaction here. This phenol, yeah. Okay. One very easy way to identify phenol is using iron 3 chloride, FeCl3, which is yellow color in solution. Okay, you can get in the lab very easily. So this fellow here, I will explain to you that FeCl3 can be used to show the presence of ethanoic acid. Okay, in Form 5 is a famous question in your practical. And can also use to show phenol. Okay, phenol will give you a purple color solution. You can ask a teacher who will show you in the lab. All right, purple color. So that the colors, here's orange and here's purple with FeCl3. With aniline, you use another fellow. You use bleaching solution, which I'll explain later. So you get a color change as well. So just to let you know that there is a certain solution to give a color change to want to prove it is phenol with FeCl3. And this one here, which actually use a bleach, calcium hypochlorite, also purple color. Okay, later I'll explain to you. Now here I want to bring out this point here is that this equation. I'll put a red color, so it's blue color. Okay, this equation here. All right, now you will look at it carefully here. What actually is form is this, here. All right, this compound here. This compound is basically like this. All right. Okay. See the H comes out here as H plus, and you get your phenoxide ion. So O minus. Okay. Of course, then your H plus. Plus H plus. The H plus right with your Cl minus to give you your HCl. Right? HCl. Of course, this one here and your Fe3 plus here. So you need 3 of them to complete the balancing, is it? So it's this one here. Okay? So it's Fe, this of 3 plus is 1 minus, so it's OCH5Cl. Okay? Now this is the marking scheme, See? Neutral iron 3 chloride. Neutral, of course, is the condition, but they don't really bother. Your FeCl3 will do. Right? Observation. Alright, this is the reagent to test. This is the observation to see purple color or violet. And they ask you for the equation. Okay? Simple equation will do. Okay, don't try to figure out some complex things. Okay? So 1 mark each. 1 mark each. This is for marking scheme. I forgot which year was it, but I just download here just to teach. Okay? All right. Now this is your FeCl3. Now the other one, of course, is just to show you here, and a passing question, 68. 68. That's down the line here. I told you that for esterification. Okay. See here. for esterification. Now compare, this is of course, this is a, this one here. Now this is a normal aliphatic straight chain alcohol, but this is the phenol. One of the main difference of these two is how to produce an ester. See now, for your ethanol, very simple, isn't it? Right? You can do it straight away with your ethanol acid, like CH3, C and H here, I told you, and H here, and your OH here, and your carboxyls, you just reverse the formula, okay? Easier to write. Okay? You can produce an ester straight away. Remember, the OH comes out from here. Right? Get your ester, which is here. Of course, with corn H2SO4, and you heat the flux. But here cannot. Phenol cannot react. I'll draw for you here. Phenol, H here, even though you look as if you can, but cannot. Okay? Plus any acid. Whatever here. Okay, R here. Here can be benzoic acid, can be your CH3, whatever here. Cannot react. No reaction. Okay, now. Right? Because basically this filler here is a solid. Okay, cannot react. To make an ester, you have to use your acyl chloride. Then you can. Okay, like here. Okay, now this is a phenol. And later you learn acyl chloride. Okay, I won't teach you now. Okay, and any acyl chloride. Okay, let's say C double bond O, and let's say CH3 here. Very simple. This H here come out. Very reactive. So the normal. Sorry, here's an O. I forgot. The normal carboxylic acid has got no reaction. But acyl chloride got. This is how acyl chloride. This is how you form your ester. With your phenol. Okay, now you must use acyl chloride. Okay, now it come out. This no reaction part here came out. Okay, I'll show you the question. Okay, it's in page 82. 82. Okay, see here. Right, now this whole thing here is a summary of all the reactions. Okay, of phenol here. I thought I mean I didn't go through. I asked you to do it, but don't care. Okay, now I'm not going to do all this thing for you now. Here, see here. They say here. If no reaction occurs, right? No reaction on the products box. Here now, see phenol plus your carboxyls in it. Right now, see here, right? Okay. So what you put here? Of course, the condition here should be no reaction. Now you see here, the marking here. See, no reaction. Okay, make sure. So phenol with any carboxyls, no reaction. But if you use acyl chloride, cannot again. If you use acyl chloride, okay, I put down here Cl, carbon, oxygen, and your CH3 got reaction. Okay, so it will come out. Give you a white fumes. Okay, fumes, dense fumes, white fumes of HCl. And of course, your what? Your, well, ester is formed, this ester. Okay, you can put the ring here. Right? O, C double bond O, and your CH3. This is ester form. So can. Okay? So just thought of I thought about this, so I thought I'd better explain carefully. Okay, so now we are done. So now let's go to your amines, which is page 88. Yeah, page 88. And we have finished the first part of formation. No, we have finished formation already. Okay, here's yesterday's notes, the day notes. Okay, formation. Right, the whole thing we have finished. Okay, now today I'm going to talk about basicity. All right, basicity. One big topic about here. Basicity. They ask you for definitions, equation of amines. Remember here the amines, guys. The amines here refers to aliphatic. Aliphatic means straight chain. Means, okay, for example, your primary, okay, your can be secondary and tertiary. Okay, like this is your CH3. Don't know why it's a TikTok like that. Okay, and N and H2 here. Okay, this is your primary, secondary CH3, okay, and of course CH3, and H, yeah. Your tertiary, which is of course N, I put N here for that. CH3 or CH3 here. Okay, you're going to deal with all this here. All right, these are tertiary. All these, they are all basic. Which is more basic? Of course, you will have to compare with the mother, ammonia. Okay, we will look into this. H here and H here. Okay, now the other one, of course, amines here, you also need to talk about your phenol amine, this one here. See, phenol amine, which is your aromatic with the ring, which is the ring here. All right, and of course your NH2 here. Okay, so all well, 1, 2, 3, 4, and 5 on the basicities. Okay, now let me just show you the questions first. Right, they always ask you to compare. So, and then I'll teach the substance, and then you try to figure out in your mind how to answer them and look at the past questions. I hope we can finish it to go into a bit more of the directions, but if cannot, do bad lah. Okay, page 103. Taste the water first. See the aim from the beginning. It's your CIE exams. All right. Now here, see they give you something like very funny one. No, they won't. This is of course easy. Propyl amine, very simple. Okay, 3 carbons here, and H2 is a primary amine. Phenol amine again is okay. Of course, primary amine, no. Remember, these are both primary, and this is a primary amine. Yes, yeah. Okay, now this one is like ethanol. Because see this is ethanol, but of course here, okay, ethanol, but the H here is substituted by an NH2. Don't care how it's got it. You can actually do it one, but don't care. So it's called ethanol amine. So there are 2 functional groups here. There's an amine group here and your alcohol group, your primary alcohol as a 2 is here. Okay. So they talk about here ethanol amine and phenylamine are 2 organic bases that are industrially important. Ethanol amine is used for solvent with basic properties, while phenol amine is important starting material for manufacture of dyes. You will see later. Okay. And pharmaceuticals. The following list give the properties together with those of propyl amine. Okay, compare. Of course, the first question now, see here, they compare on these 2 here, right? They compare the boiling point. Okay, see. Suggest why boiling point of ethanol amine is much higher than propyl amine. Draw illustration. Draw a diagram with illustration. Of course, here can only form 1 hydrogen bond, isn't it, among themselves, but here can form 2, isn't it? NH2 with NH2 and NH2 with OH. Now see how the answer in the past question, okay? The marking scheme. See now, hydrogen bond because of hydrogen bond, or more hydrogen bond, right? Now diagram. Now this of course is your ethanol amine. So first you see now here, all right? Here you draw with here. See now, okay? You should draw 2 of them, here all, but of course you can draw both. So the hydrogen bond with OH and OH here, and OH with NH2. So, draw 2 better, because they don't know what they want. Because the OH here can bond hydrogen bonds with the H here can bond with O, the O can bond with H here, and the O and H can bond with the NH2, isn't it? Right here. All right. Draw for you lah. Some of you are gundu, I tell you. So this one here is actually. Okay, I need to draw this again. Okay, red color. So So here you will see, you want to draw it here. So they say draw it out, the diagram is it? Oh, now you want to draw the oxygen can. So put a delta negative here, 2 electrons here, this delta positive. And then draw here the H, okay, H here to the O, 2 electrons here, don't care about the sign here, this is on the bottom here, this delta positive here. So dot, 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 this is your what? Hydrogen bond. Okay now, so to be exact, you can draw like that, or in this case here, you can draw like that. C, H here. See, you must draw this out to specifically know that you know your stuff. Okay, to the H here, right? To the thing here, draw the delta negative, delta positive. You can draw the H here as well, doesn't matter. But here I draw the O, that means you must go to the H there, right? Okay, I draw that one now. Anyway, H here and here, all right? H here and blah blah blah. Delta positive here, this form. Or you can draw the other one here, like here. You can draw like that. H here. Draw the hydrogen. Okay, O to the hydrogen. So you don't use the electrons in the oxygen here. Delta negative is delta positive. Here is your what? Nitrogen, is it? So H here and H here. And C right here. Now there is a lone pair. So delta negative is delta positive. Dot, 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 dot. Either way you can draw. All these are what? Hydrogen bonds, So because they ask you to draw the diagrams, here, you can see specific here, right? Sorry, wrong number. Oh, yeah. See? Draw a diagram to illustrate your answer, 2 marks. Okay? Okay? Now let's go to the basic stuff. The basic, okay, here. The first one, all right. Describe and explain the relative. It means you compare. The word relative here means compare. Relative basicities of propylamine and phenylamine. Means which is more basic and why? 2 marks. Describe means that which is more. Explain means that why is it more? Why is less? They also ask you now, write an equation to show the ethanol amine acting as a bronze state laurate base. What is a base? Remember, acid is a proton donor, a base the proton acceptor, that's all. Okay? Remember, I say again here. What is a base, bronze laurate base? It's a proton acceptor. That's all. Don't say any more things. Okay? They say acting as, which means here the equation here. So you draw, of course, the alcohol will not be the one here. Okay? Alcohol will not. Alcohol is a very mild weak acid, not a base. Right? This fella here is a base. Lone pair here. So now you can, if it's a base, you must write with an acid, is it? Right? You can put it means it must be a proton acceptor. You can use HCl, you can use water, whatever you like. If you use water here, which sometimes they put water there. Reversible. Okay. Right? You will give you your OH here and your CH2 here and your CH2 here and your NH3, isn't it? Positive. Right? Because it go to here and this one will go to here and will give you your OH minus, see not? Right? You can use that or you can use HCl. Doesn't matter. Okay, so this is very one direction. Don't get CH2 and of course your N. Now if you draw the whole thing here, should be 3 hydrogens here. And a positive charge here and a dot Cl minus, no water there. Okay? Either way will be the 1 mark. Okay, the marking scheme. Right? See here. Right here. See that? Can you see that? H plus look at give you the NH3 positive here. Why NH3? Because there are 2 hydrogens here. You see it? Can I see? I will just, this is it. 2 plus 1, 3, isn't it? Okay. Use HCl, you must put the Cl minus here. Use water, it's on here. Okay? All is acceptable. Okay, acceptable. Okay? All right, now, just one more now. Okay, I'll just show you one more first. Okay, now here you compare your aliphatic, right, with your aromatic amines, the basicities. Okay, I'll show you one with the aromatic one, aromatic one comparison, aromatic. Okay. Let me see, I compare. More than that, 112. You compare with ammonia as well. Okay, then we will start, otherwise no time. Right, now here, write an equation for a reaction in which ethyl amine act as a base. Simple, isn't it? Right, same thing here, plus water or plus HCl. Now here, ammonia, ethyl amine, this is aliphatic, right, straight chain. Phenol amine, this is a ring, are 3 nitrogen containing bases. Place the 3 compounds in order of basicity with the most acidic, most basic first and so forth. Why you place them? Okay, the whole thing here. Again, they ask you for write an equation for phenol acting as an acid. This before then, right? If you have not got this, quite simple. C6H5. Remember, it is a proton donor. Proton donor. You can write a few things. You can write the first equation, which is just dissociate, can already. O minus plus H plus, right? Or I can put plus water. Same thing here, right? Use C6H5, O minus plus your H3, O positive. Or plus a base also can, plus NaOH also can. Okay, one way, because it's very, very reactive with C6H5, O minus dot Na plus, sodium phenoxide plus your water. Okay, all this can be done, up to you, because it's just a proton donor. Okay, now so I told you here compare with the 3, is it? Now let's go to our theory, page 18, down here. So they say describe and explain. It's stuck. I'm not moving. Okay. It's going to spoil already. I see. Because I think too much writing on this, yeah. So if I get stuck, because they need to superimpose and see get stuck. Never mind. No choice, no choice, no choice. Okay. Describe here, describe and explain basicity of amines. So we're going to look at one shot. Okay, now. Okay. So we go to theory first and do a few questions. Right. So here we have, now remember, what's the base? Brown-Sid Lorry, it's a proton acceptor. Why is it a proton acceptor? Because all of them, nitrogen here, has got 3 bonds. So there's a lone pair here. Why lone pair? Because this is group 5, isn't it? 1, 2, 3, 4, and 5. Right? So this is your cross here, and cross here. That's why nitrogen is most like this is negative 3. It's positive 1, positive 1. Positive 1 here. Why positive negative 3? Because it has taken 3 electrons from nitrogen, or from hydrogen. This is a negative 3. This is the oxidation state. Okay. All right. Okay. Now, of course, it forms an ammonium. Okay, because this one here will form a dative bond here. Okay, so it's plus 5 here. Right? So now you can put in water in terms like this here also can. That means you take the hydrogen from here, give either equation, you get a mark to show that ammonia is basic. Now here, pKb again. Now I told you the P here represents what? Minus log base 10. This is a mathematical symbol. Like I told you pH what? Is equals to minus log base 10 H plus concentration. This is your water base. Yep. Okay, so blah blah blah. So now remember the lower, we will see this later in our A2 physical. The lower the pKb, the more basic, or lower the pKa, the more acidic. Same idea. That means you can see here is the lowest. That means This one here, right? More basic. As you go down here, that means become more basic. More basic. This is the most basic of all. Most. Now, tertiary don't have a tertiary is different. Tertiary, the explanation is different. Tertiary in fact is less basic than your secondary. Okay? This is your ammonia, primary and secondary. If you want to go over again, this is your ammonia, right? This is a primary amine, secondary amine. So secondary amine is more basic here. Okay? Now why? Why is this basic? First of all, because of the low electron pair. See? All right? See? I'm going to draw it here. Okay? Ammonia. Okay. Lone pair here. Okay? Primary amine and CH3, let's say. H here and H here. And lone pair here. Secondary amine, CH3 and H here and CH3 here. All got the lone pair here. Okay? So let's say if it means I will change the color. Color. Okay. I want to put it with H plus because why a Lorry Brownstead Lorry base is a proton acceptor. That means if you accept the proton, what must it do to accept the proton? And you want to tackle a girl. What must you have to tackle a girl? Now you must have a car, man, and maybe a credit card, or maybe some gold or whatever, stock and shares. So what is it to attract the H plus? The lone pair. How to attract a girl? You not only must have your credit card, you must let the girl have your credit card. If you're a strong attractor, it means your credit card very easy to go. Easy to, darling, I can use it. You stingy, that means you're not very, you're not very strong attract the girls. Too bad. The girl like your car, say, oh, darling, can use the car anytime. Easy. Donate your car to her. Means you're a very strong attractor. Same thing here. The strength of the base depends on the availability of the lone electron here to donate, to protonate, or to react, or be detonated. Now, the marking scheme is to protonate, okay? Protonate. Okay? So, this is to protonate, to donate here. Dative one, isn't it? This is dative one, Dative one. Of course, to form what? NH4 positive, Okay? Same thing here. This one will be donated to the H plus, Same thing here. To the H plus. So how easy is it for the lone pair here to be donated to the H plus? Right? How the Q is availability. You can see this one coming out in the marking scheme, okay? How available is your credit card to the girl? How available is your car to the girl? Or to the boy, you want to tackle the boy. Okay? So here, remember, these are all hydrogen. Use the word inductive effect. Inductive effect. Remember now? We did before, is it? The H is 0 inductive effect. Okay, 0, 0 is a reference point. R group are electron donors. So R group here. Okay, CH3, C2H5, whatever are electron donating groups. Donating, you see this coming out. Okay, so they give electrons. Now here, push electrons out. No, nothing. Push electrons, that means that the electrons are more available. Oh, let's go like your mother is like go la, push you to give the car to the girl. Give her. I got two mothers here will say, go la, give more your car more available to the girl. So this, of course, this pair electrons here is the most available here, more than this one here, right? That's why your secondary is stronger base and this is stronger than this. Yes, not. Now let's come now. Don't talk about tertiary. It's a different ball game. Okay, I won't tell you now. Now, let's say now if it's your amine here. Okay, here, all right, and linear. Same thing here, right? H here, and H here. Don't compare. But you know, something happens here. I will draw it here, okay? Otherwise, cannot see properly. Now, this is a flat molecule. Remember, the benzene ring is a flat molecule here. And we have the pi electron cloud here, yes, yeah? Down here as well, up and down, okay? Okay, now won't draw the hydrogens here, you can feel it yourself, okay? But there's a nitrogen here, and this is all flat. Why? Because sp2 is in. So, you know, the lone electron pair is here in the p orbitals. They're able to resonate or delocalize. Okay, they call it resonate. The lone electron pair resonates or delocalize into the pi electron cloud. Sorry. Therefore, this going inside here. Oh, that means this one is less available. It's there, but it's making it less available. To who? To the girl, to the H plus. Therefore, it's less basic. The least basic than even ammonia. Okay? So that's the reason why. You can see all here, okay? Lone electron pair, blah, blah, blah. You can read yourself. Okay? Making it less available. The key word is, of course, here, less available to the H plus, to protonate, making it the weakest base of all. Okay? Now, let's say you compare all the three here. Of course, if you have a group here that is being substituted, bromine, that means this fellow here will be the proton acceptors now. Yeah. Yeah. So, bromine, because it's electron, withdrawing. That means here is worse, This, of course, hydrogen is neutral. This is pushing. That means this is a bit better. This one is a bit better base than this one here. But this is the worst base of all, comparatively with the substitute group here. Okay, now, right? Simple as it. Okay, now let's look at a few questions, then we go on, right? Okay, now the first question here, which I got just now. Let's get a marking scheme 103. 103. Okay. Now here. Describe and explain the rating, the relative basicity of your propylamine. Right? Propylamine, of course, is this one here. Right down here. CH3, CH2. I'm going to put this separately here. It's propylamine and H. I'm going to put H here and the lone pair here. Alright? Right? So here and your phenylamine. Okay? Describe. One mark is, so which more basic? It's on here. It's more basic. Why? So the first mark is that is more basic. Okay, why? Because this group here is what? Is electron donating. Right? Making the lone pair here more available. That's not. Here. Right? The pi electron, the lone pair here. What happens? Delocalize into the pi electron, making it less available. Now look at the marking scheme. Alright. Second one. So right now here now the first mark, propylamine is more basic, 1 mark, 1 mark here. Okay. Now the two reasons here, either one is 1 mark. You can give both you just get 1 mark up to you. Okay, but in exams you of course write both because you don't know how the stupid marking scheme is. Because the lone pair of N is delocalized over the ring. You feel what I mean? Making what? Less what? Available for protonation or available for the H plus if you cannot use the word protonation for H plus. Same. Right. The word is availability. How available is your car to the girl to use? How available is your credit card for her to click, ting tang like that. Okay. Or the propyl group, which is what? Which is your C3H7, is it? It's what? Electron donating. Why? Inductive effect, is it? Inductive effect. See now. Okay, so you can see here. Right? So the lone pair is more available, is it not? The word. Either one, you get 1 mark. Boleh? Okay, boleh, Okay. Now there are other questions here which I just shoot off for you. You can go and do it by yourself, can you? Okay. I'm going to put here because of time. I want to talk some more. Because, no. Okay, the other questions here are in page, okay, 112. All right. Then page 397, okay? Then 390. All right. Now I'm going to talk about 340 now. Quite an interesting part. 340. Okay. Now try all this yourself. 340. Remember, you don't do it, your problem. You know. You be lazy, you bloody fool, you're an idiot. Okay, now here same thing. Right? Now explain why ethyl amine is basic. Why? Because it's a proton acceptor. Okay, now look at the marking scheme. 12 November 43. I hope I got it here. 12 November. Yeah, I got it. Now I go back to that one. Sometimes it's, teaching is not so easy. 12 November 43. Oh my, this was a bit of time. 12 November 43. 12 November 43. 12 November 43. 12 November 43. Okay, coming up. 43. Okay. Bigger. All right. Bigger bit. Okay. What question is it? Question. Okay, here. Okay. Now, look at the question, guys. Right. Why? Say why? Why is basic? Because it's got low electron pair. Right? Must say low electron. Not that it can react. See, can react with H plus. Yes, this is actually this part here, right? Is actually Roy Brown's definition of a base, right? But then why? Why can it? Why is it? Because lone pair. See, lone pair is important on mark there. Yeah. All right. Now next part here. Write an equation to show that ethyl amine is a base. Very simple. Is it? What is it? Of course, you write with ethyl amine is C2H5 and NH2. Okay, it means plus protons. You can use H plus or you can HCl or waters again. Okay, to give you what? C2H5, what? NH what? 3 positive, dot Cl minus A. Or you can put water. Now let's look at the marking scheme. Right, you can put water. See now, HCl, yes not. Right? You can also use water, isn't it? See, water. Sorry, here, water. Alright? You can even put acid, hydroxide ion, okay? Yeah. The second part is even more interesting here. As a nucleophile. When does this act as a nucleophile? That means nucleophile here, if it's nucleophile here, that means this must undergo what correction? Nucleophilic substitution. Nucleophilic substitution. Okay, obviously, SN, is it? Now this of course is, you remember not, your alkyl halide, remember not? Your alkyl halide, remember? Your alkyl halide is the only one that is in your syllabus that has got the mechanism. And Cl, and of course, if this guy here continues, remember, this one here, if you start with ammonia, you get your ethyl amine, isn't it? Right now. Yeah, but say Cl. You got plenty of this fellow here. This one here can continue to act as a what? Nucleophile. Yeah? See? H. Yeah? And Cl here, data negative, data positive. Remember not? So they twist it around, which is a very good question. C2H5 and H here. Yeah. So this fellow here now can, of course, here is the ammonia, act as a nucleophile. Data negative, data positive. Yeah? Right? This one comes out here. So now this one will go inside, yeah, to attack here. So it comes out here, yeah, and the hydrogen comes out here. So this is a nucleophile. See, so you ask you for an equation, okay, which means this equation, this equation here, right? Which will give you what? Of course, give you a secondary, isn't it? Right? If you attack here, give you CH3. CH2, right, and to your N and the CH2 phase 5 and your H plus your what? Your HCl. You know. Yes, you can see from here the marking scheme. Yes, yeah, okay. Right, anyone will do. Okay, right, attacking an L. This is of course your alkyl halide. Need to do again. Okay, remember? Can be the same one, whatever. Now, of course, it's acyl chloride, so don't worry first. Okay, right? Okay. I forgot to look at the time. What time I begin? I don't know what time is it. Never mind. Okay, can? So we have finished part right now. I just want to go to just a few ideas, and then I think we'll stop now. Okay. We've done quite a lot today, actually. Okay, page 88. Here, we've got to wait a while. See, not moving. Okay, the thing must come up. Okay, because I saved it. Now here, the second part here. Describe, okay, reactions of phenol amine with aqueous bromine and nitrous acid. Nitrous, not nitric acid. This one here, I done the first one already with bromine. It's this part here. This is of course your, see, along here, see, HNO3. HNO3 is your nitric acid. Nitric acid. HNO2 is a nitrous acid. We done it before in your practical. Okay, right? Nitrous acid, right? Okay, this is prepared freshly. Now this is very unstable. It's a pale blue color. It's a pale blue color. Pale blue solution. Pale blue solution. Very nice one. But it's very unstable. It will go to this one here. Right? And you can give out NO2. It's like in your practical, you get a brown gas coming out. Remember not? You forgot, of course. You can make this with sodium nitrite plus HCl aqueous. Okay, very simple. Okay, you can see later we will use this combination because why? Prepare fresh. Because this is not stable. This is not stable. Okay, so here, right? So now, and of course, E will actually is this reaction. Okay, I'm going to give you the whole picture first of D. Okay, then we will stop. Right, D. I'm going to go down here. Stuck. Okay. Right. Okay, now see in my notes here in page 92, there's this thing called salt. Remember this? You know, I put this on here because in most books it acts as salt, form salt. Okay, salt formation. Salt means what? Salt means there's a cation and then anion is ionic. That's the idea, which is true. It's a base, it's an acid. So you form a salt. Okay, now it's written in this funny way, right? Instead of like ammonia plus HCl, but you get ammonium chloride. Yeah. Okay. So here's actually NF plus. Okay. Instead of hydrogen here, you got R group here. That's all. Okay. So remember now, this your phenol amine is a liquid. Okay. It's a liquid, but it is not soluble in water. Liquid. It's not soluble, not miscible. They call it not miscible. That means it won't dissolve, or immiscible. Like imbecile, no. Immiscible. Okay, with water. But you put acid inside, they will dissolve. That means they form one homogeneous, okay, form one solution. That means it dissolves. Why? Because they form a salt. Why is salt soluble? PAS, remember not? PAS, you don't know what PAS. It's an ammonium salt, isn't it? It's an ammonium salt. So it's soluble. Okay? Now the next one, of course, is this one here. Now, I would explain this later, okay? But I want to show you this one here. Okay. Now these two reactions here. Basically, I'm going to round up here as saying, now I put here as see. Okay, now this is your phenol amine, yeah? See, phenol amine also can form a salt. Okay, where is it? A salt. Okay, see how it's going here. So phenol amine here. Okay, so this, all this. Remember this primary, secondary also can. Okay, two I put NH. Okay, right? Plus HCl. Also can form a salt. Okay, just to make it clearer, okay, so that you won't be so, well, I don't know. H here, positive and dot. Okay, also a salt. This is secondary amine. Tertiary also can form. CH3. So get down to write all these things in your notes so that at least I don't know, okay, plus your HCl also can. At least you know, you experienced in your hand, using your hand, all right? And CH3, and H, and a positive, okay? It's all new to use it, the salt, okay? Of course, if the quaternary ammonium salt is when you continue, quaternary ammonium salt is when, quaternary ammonium salt is found when this continue, this acts as a what? As a nucleophile. HILE. That means you form your N, CH3, 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 CH3. This is a salt. This is quaternary salt. Okay. Now let's go back to the one here, and then we're in now. Okay. Now here, this one here, because it has a ring, so now this is called a side chain. Remember? Now this is called a ring or a nucleus ring reaction. So there are two. Okay, now we talk about the ring first. The ring one is very simple. I told you that because of the lone pair here, right, delocalized inside here, it will make the ring more active, isn't it? Right? So the lone electron pair delocalize into the ring, You know, more reactive. Towards what reaction? Towards what? Electrophilic substitution. Electrophilic substitution. Of course, the main one is with bromine aqueous. Just like your phenol plus Br2 aqueous, right? Remember this one here, if going inside here, your 2 and 4 are activated. So you get 3, one shot. Just water, no need any halogen carrier. Very fast, man. In the lab, you can see, okay, YPPT one shot. Okay, with this, we should go do the lab. So now can do or not? I don't know. See, 3, 3, 3, oh, 3. Just like your phenol HBr here. 3. This is your tribromo. Tribromo is called tribromo. Phenol Amine. Okay, this is the white PPT. Ah, very good. You can see it, right? This is your colorless solution. Colorless solution. Okay, so you can observe it very clear. And this is frequently asked. See here, you can see I talk about here. So here, okay, right? I think I will stop here. But before I stop, I want to show you that how this bromine fella can come out. Okay, just a few. Won't be so jump, but it's 105. Okay, very commonly asked 105. Okay, see now, see, it's just a structure formula for products A, B, C, and D, following the blah blah blah. See now, right? Don't care about the chlorine. I told you that in a ring there are 2 substituent groups here. They will act independently. With bromine, of course, you go to what? Your 2 and your 4. See, 4 is occupied. You don't get that. So of course you get what? NH2 here, and of course the 2 and 4. You keep the Cl here. Don't care. They don't care about each other. One Br here. Remember is aqueous here. Yep. Okay. Now remember this is the base. This is the base. So here no reaction, man. Don't be afraid. If I put HCl here, quite common HCl aqueous. What do I get? Here I get NH3 positive dot a Cl minus in, and the Cl remains unperturbed. The OH cannot kick out the Cl. Why? Because the bond here is strong. Remember? For normal alkylate, you can kick out the Cl. Right? So this is the very common reaction, the ring reaction. Okay? So I think I'll stop here. I will do the other one later. Right? Remember this. I'll do one more. That's all, and then we'll finish off your amines and amides already. We are almost halfway through already. And if you have not catch up, I hope that you will do it by yourself, because your life is at stake. You want to fail, you go ahead. I do my job. If you don't do your job, you can waste some money and you can tell your father, I'm not interested in A levels, I want to fail. Okay? So, okay, see, I did so much work up prepare here, marketing scene, but no time to do. Okay? See, if I work hard, you also must work hard, you idiots. Alright? So now we want to stop recording.